As Alison has mentioned, my name is Ariel, and I am a volumetric stage engineer working at 8i here, based in Wellington. We have offices here in Wellington as well as in Chicago in the States, but currently most of our stage building is based in Wellington. So what does a volumetric stage engineer do, and what does that even mean? Currently, there is a problem in the VFX industry, so that's the visual effects. So any special effects that you see perhaps in movies or games that requires digital design or work, that is what we describe as special effects, visual effects. So here, as you can see on the screen, that there is a very, very basic human model. This is Steve from Minecraft, if you're familiar with it. So he's basically, your rectangular shapes and having textures projected onto that shape to show his face, his skin, his clothing, and that's how that model is represented. But here you can see in more complicated and more, I guess you could even say, more realistic to real life models. They do get quite complicated, and every single one of these requires a team of artists in terms of sculpting the model, and then on top of that, coloring, shading every single aspect of the model. And what gets tricky is that for every single costume change or anything in terms of equipment that any of these characters need, that will require modeling as well. So like the character on the very right, he has a keyblade for a weapon, and with the different keyblades, all that needs different modeling and different artists to work on. So as you can see, that would take a lot of time for artists to sculpt and then do the coloring, the shading, all of that. So it's a lot of time consumed and cost consumed for companies when they want to create movies or games. So how does 8i solve this problem? So we take that problem and we reframe it so that we can have human models rendered from video images instead. So how does that work? We build stages. So this specific stage here is one of our smaller stages, and it's made out of aluminum beams, as you can see, pointed with the blue arrow. And then inside the stage, we have lights. This is to illuminate the model within the stage. So because we don't want any shadowing to be recreated, we want purely just the outline of the person. Lighting has to be illuminated equally from all angles of a person. And then this is the star of our stage, the cameras. This specific stage has 2K cameras, so that's 2K resolution. For this stage, there are about 30 cameras in the stage. So as you can see, the middle red circle shows you 3 cameras pointing towards the model, and then the other rail has another 3. So there's just cameras spread across the stage so that we can capture a person all 360 degrees. So what does that mean? How does that data get used? I can show you here. So as a child, one of my favorite movies to watch was The Lion King, and this is an iconic scene if you've seen it or if you're a fan of it. Um, this part where Rafiki raises Simba into the sky, and it has amazing music playing in the background. And if you're an animal lover, of course, like me here, you would have to recreate it. Right. So this is video footage from a single camera from the front rail. So we have different angles, and then one you could classify a rail of cameras as your main camera. So this is raw footage. So this is straight out of the camera, and this is the raw footage that you would see when you do a recording. So what we do is we take this data and we get rid of all of the background noise, and we can capture the model itself. And then this is just a short sequence from what our software can output on the right. As you can see in that, my other dog, Cookie, on the floor, he gets clipped in and out. That's because if you go back into the middle image, you can see that he's actually going in and out of that some masking tape region in the middle circle. So that's what we define as the capture zone. Right, so if you imagine cameras 360 around, there's a camera from a certain angle. At some point, it's not going to be able to see anything beyond at a certain point. So we mark stages with a given boundary so that anything outside of the circle, we can't recreate that accurately. So that's why he's getting clipped off in the third image there. Right, so as you can see, the footage from all cameras, we take all of them and we compile them to say, all right, match all of these images up, all of the data, and then we can actually extract the model in video format and play that back in a 360-degree manner. So from here on out, what our clients do is they take this asset and they can import it into any other external software and put it into whatever they need it to be, whether it be a game or a movie. And then this is really easy because now they have this this asset that has no background and nothing else along it. So technically, I guess if I had the expertise in it, I could get the software installed, and then I could draw the moon or model up the moon and then place myself and my dogs on top of the moon. So that is what our clients tend to use our software for. Right, so how did I get here? How did I come to work as a volumetric stage engineer? Well, I first started studying a mechatronics engineering degree at the University of Canterbury. And that's a very fancy phrase or term that not a lot of people are familiar with. So a very basic mechatronics system is an elevator. If you can imagine, an elevator has quite a few components in it to make it work. So you have your pulley system, so that's a mechanical based system. And then you have motors, electric motors that powers your pulleys to pull the elevator car up and down. And then on top of that, you need software in the background, which handles all of that. So that would be giving it some form of intelligence to say when you're in level 1 and then you want to go to level 2 and there's someone someone else in the building wanting to go somewhere. So the software behind that has to perform that logic to know, okay, where do I go first, and so forth. So you have your three main components in the mechatronics system. You have your software, your electrical system, and then you have your mechanical parts. So that is what a mechatronics engineering would look like. And before I started studying at University of Canterbury, I studied at Wellington Girls here in Wellington. And my favorite subject was math. But when I was in high school, I didn't particularly have an interest in engineering. I always wanted to be a baker. I like doing baking in my spare time. So obviously I thought, okay, I'm gonna grow up, I'm gonna become a pastry chef. I'm gonna, make these amazing and beautiful foods for people. But then I came across, I guess, a convention, an exhibition, and someone, showed me that this is how you could apply my interest in mathematics in a very logical and practical way. And that's how my interest in engineering sparked. And I picked mechatronics because it had such a variety of things I could learn as well. It wasn't specific enough that I couldn't learn other different aspects of engineering, which is why I picked this this path of engineering. My proudest achievement throughout my career has to be the time my team designed a robot and we came second in a robo competition. So this competition, the aim of it was to design an autonomous robot, and for it to go around an arena and pick up weights and bring it back to what you would call home base. So what an autonomous robot means is that once you turn it on, it just goes. You don't control it. You don't have a controller to tell it what to do. It has all of the software and intelligence programmed into it to know what to do. So for this one, there were a lot of different obstacles and different criteria. So around the arenas, we have weights of different masses, and we also had dummy weights, which is plastic weights designed to fool the robot and trick it. So there were just different things that we had to design around for this competition. And here you can see this is what me and my team came up with. We had sensors on top and sensors on the bottom, and to pick up weights, we had a magnetic strip. And we had tractors on top of the wheels just so that we could navigate the terrain more effectively. And this was also really good life lesson for me in terms of my engineering career, because what you initially design may not always end up, may not always look exactly the same as your end product. So this is what our end product of our robot ended up looking like. As you can see, there are just slight modifications to it. We added like an additional wheel, and then we also added this bar on the top. So that's for when we toss the weights onto the back, it would slam down more effectively. So that's how we can collect the weight better and store it in the back of the robot. So yeah, part of engineering is that you would have initial design and then just continuously to improve on that. So definitely one of the bigger life lessons for me. So key STEM skills that I use every day. Coding. As you can expect, being able to take all that data from all those cameras and being able to recreate that into a single playback that is smooth and understandable to clients. It requires a lot of programming and coding in the back for that to all work together. And then I also have to creatively think a lot because we have so many different clients and all of their stages are built slightly differently because we custom make them for each and every single one of our clients. So they may have very different problems from one another. So we constantly have to think on our feet to help solve their problems and to provide them with a product that works well. Part of engineering as well is that you have to be able to communicate effectively. Specifically for my work, because we have to work collaboratively with the other team based in the US. That's where all of our codec software engineers are. So for a lot of things, we have to work with them and communicate effectively. So we are all on the same page and understand each other. One thing I wish I knew at your age before pursuing a STEM career. I guess when I was younger, I always had this mentality that to just rely on myself. If I don't understand something, I can try. I will try really hard to learn it by myself, and that's how I've always been up until I guess the middle in the midst of my engineering degree, because I learned it the hard way that sometimes it's okay to ask for help. There's so many different experts in the field that it's impossible for one person to understand every single aspect of engineering, especially in mechatronics, because you have 3 different systems. We tend to be jack of all trades. We know enough about everything, but we're not particularly experts in them. So it's really important to know when you should be asking questions, because not only do you come up with better solutions, you can actually understand things better, and what you come up with tends to be a more well-rounded product as well. Right. Do we have any questions? I think we do.
Yes, there's a couple of questions there for you to answer, Ariel.
Yes, I am just bringing them up right now. Okay. All right, we have a couple of these. Right, first question. What movies have you worked on? Right, interesting enough, I have not worked on any movies, but I know that our software has been used for for promoting movies. I believe it was Spider-Man Homecoming, whichever is the one with the oh, what is his name? The newer version of Spider-Man. I believe when they were in production, they used one of our old stages in LA for their promotional to produce promotional content. So at one point we did have Spider-Man using our software. So that was really cool. Next question. Do many girls do what you do? No. So sadly, I say sadly because I do wish that there were more women in engineering, just because then I feel like, just because then when I was younger, I would have felt like, you know, there was a role model for me to look up to. But no, there isn't, we're not the majority, but I am finding that there is a increasing amount of women in entering engineering, which is really good and encouraging to see. So for all the girls out there, if you're interested in STEM, I would hope that you would pursue a career in STEM.
Ariel, thank you so much. That was a really inspirational presentation. We absolutely loved it, and I think you would have inspired many more young women to follow in your footsteps as a role model. Thank you so much, and I especially liked your analogy of the elevator with explaining what mechatronics actually is. That was amazing. But thank you so much for your time on behalf of the Wonder Project. That was just fabulous, and enjoy the rest of your day. Thank you so much, Ariel.
See you.
Bye.
Bye-bye.